The aircraft is a good example of something that can't be allowed to go wrong. It's actually wonderfully safe. This isn't a plane crash, it's a scrapyard. They're mostly bits of 707 over there with a Hunter on the top there. I love scrapyards. And they're actually quite good places to see how planes are made. All aircraft are designed to be fail-safe, or to use the technical jargon, damage tolerant. For example, there are 2 joysticks, 2 sets of control wires, and a lot of the wiring is duplicated. For all the essential systems, there are backups. But this isn't infallible. For example, in the DC-10 crash in Paris, when the cargo door fell off, the cabin floor collapsed, and this severed not only the main cables, but also the backup cables as well. When all the parallel systems fail at the same time, this is called a common mode failure. It's usually fairly disastrous. One way of preventing this is to build in different systems that work in different ways. For instance, electric power can come from generators driven by the engine. It can also come from the hydraulic system, the hydraulic pump, and it can also come from batteries, all at the same time. Since the DC-10 crash, the control lines now have to travel by different routes to those of their backups in an attempt to avoid a common mode failure. And even this is not infallible. Dead chickens like this are used in a series of tests designed to find out what happens when a plane in flight hits a bird. Bird strikes can be a major hazard, especially on takeoff. A pre-packed bird is loaded into a compressed air gun and then fired at different parts of the airframe. For example, the pilot's windscreen. A common mode failure can happen when a flock of birds stops all the engines at once. But this is rare. Usually at least one engine can be restarted, and all modern airliners are built to keep flying on just one. My most reliable machine's in Carnaby Street. It's nowhere near the same standard as an aeroplane, but it does use the same principle of having backup systems. It's a water-powered sign for a shop called Cascade, and it's supposed to operate continuously for 12 hours a day. This is the prototype in my workshop. The complete thing is 24 foot wide. We've tried to make it quite simple. There's an independent mechanism for each of the 8 fishes. There are 6 separate pumps, so even if a pump or a fish stop working, the rest will carry on and the failure will hardly be noticed. This burning desire to make the thing reliable is not through any great love of craftsmanship. The less it breaks down, the less will be called out to repair or maintain it. With airliners, on the other hand, regular maintenance is essential for safety. A traditional technique used to ensure the reliability of planes has been to assign a life to every component. At the end of the rated life, it would be changed, although it would almost certainly still be working perfectly. Every time the plane came in for maintenance, a few parts would be replaced, like this heat exchanger. However, it's obviously expensive and wasteful changing perfectly good parts. A new method of maintenance is taking over. It's called condition monitoring. Various test circuits and procedures are designed into the plane. In the engine, the turbine blades are inspected with an optical fibre device called a borescope. Oil filters are examined to see how many fragments of metal have worn away. The idea is that you run through these tests every 500 flying hours and leave everything alone unless one of the tests reveals that something needs doing. The engines are also run up to speed on the ground. A lot of information about their condition can be deduced by careful analysis of their temperatures and pressures, etc. Engine vibration is also measured. All these recordings can give some indication of parts beginning to wear. McDonnell Douglas, who make DC-10s like these, sell the concept with the catchphrase, "If it ain't broke, don't fix it." Condition monitoring has the disadvantage there are some faults it may miss. Many parts of the airframe are inaccessible and can suffer from metal fatigue without being noticed. However, since the early Comet disasters, there are remarkably few examples of this. Condition monitoring has another advantage. It's often best to leave things that are working perfectly well alone. Any repair runs the risk of introducing a bit of dirt, wearing the thread of some vital nut, or forgetting to replace some vital part. In the past, aircraft accidents have almost certainly been caused by this kind of fiddling. The principle of leaving well alone can be useful. There are many mechanisms in my machines which ought not to be reliable, but which have withstood many thousand operations. The glass is shot along the bar by an old spin dryer motor underneath. When his hand reaches the end of its track, the motor stalls. I was expecting this to burn out the motor, but it hasn't, so I've left it alone. I think this fiddling is why many vehicles become unreliable. When one thing goes wrong, a lot of damage can be done searching for a fault. Many bits and pieces are disturbed and never work properly again. A knocking noise, which started coming out of my Transit a little while ago, is a good example of this. A local mechanic convinced me that the noise was coming from the differential gear. I replaced it with a differential from a scrapyard, but still the noise remained. After further conversations with the mechanic, I decided the fault must be in one of the universal joints. I replaced both of them, but this made the noise worse. Then I noticed a bulge in a tyre. This turned out to be the source of the original noise. Having replaced that, I was still left with the second, worse noise. After fitting yet another differential to no avail, I finally cured it by having the prop shaft rebalanced. Unfortunately, I'd forgotten to put any oil in the new differential. I don't want to imply that one should do nothing to a car until it breaks down. Listening for noises, watching the exhaust and looking for oil leaks can all be valuable forms of condition monitoring. However, I suspect that extensive DIY repairs can reduce the long-term reliability of cars. A recent Which survey found that among cars over 6 years old, Volkswagen Beetles were much the most reliable. I now wonder whether this might be due to their policy of discouraging the supply of parts and repairs by DIY mechanics. Unfortunately, the flaw in this theory is that garages are often just as bad, doing just as much damage searching for a fault. I don't think there's any solution. Perhaps Victorian machines, despite their indestructibility, weren't any more reliable than machines today. Conservative design, though boring, has at least made cars more reliable. testing is not infallible. 100% reliability is almost attainable, and fiddling should be avoided at all costs. Making the machines has mixed blessings. It's very satisfying getting them to work, but they'll never be totally reliable. I sometimes fear I'll end up as a perpetual touring mechanic, fiddling with my life's work. Machines are a source of both inspiration and frustration.